Hello dear viewers, welcome to TV Math Hub. In our today's session, we shall be looking at the solutions at Uneb 2025 Pure Mathematics. So we shall begin with question number 1. It says, solve the following simultaneous equations. We are given 3 equations and we need to obtain the values for x, y, and z. So to solve these equations here, solve this system, we shall use the method of elimination. This approach systematically removes variables one by one to reduce the system to simpler equations. So for this case, we shall try to break these into different segments. We introduce the equations and we shall label them as we have seen. We call this one equation number 1, 2, and equation number 3. So from that, we shall try to eliminate x from equation 1 and 2. So let us eliminate x from equations 1 and 2. From equations 1 and 2. So to do that, it means we shall multiply 2 in equation 1. Let us multiply 2 in equation 1. Then we subtract. Equation number 2. So when we do that, it means we shall have this as 2x plus 6y plus 4z, which is equal to negative 26. We shall have this as 2x minus 6y then plus 3z, which is equal to 32. So from here, we shall eliminate x by subtracting, and this will give us 12y. 4z minus 3z will give us plus z. Then this one minus 26 minus 32 will give us minus 58. And we shall call this one here as equation number 4. So next we shall also try to eliminate, we eliminate x also from equations 1 and 3. So we shall do that by multiplying 3 in equation 1. Then after we shall subtract equation number 3. So when we multiply 3 in equation 1, it will become 3x plus 9y plus 6z, which is equal to negative 39. Then we shall be having 3x, that is equation 3, minus 4y, then minus z, which is equal to 12. We need to again subtract the 2. And here we shall get 13y. This will give us 13y. This will give us 7 z. And this will give us minus. This is 39. This is minus 51. So we shall call this one equation number 5. So now from equations 4 and 5, we realize that we are remaining with 2 variables, that is y and z. So we have 12y plus z, which is equal to negative 58. We have 13y, then plus 7z, which is equal to negative 51. So we shall again try to eliminate one of the unknowns here, and we can do that by making sure the coefficients of that we need to eliminate are the same. So we shall multiply here by 7 and try to make the coefficients the same. So after multiplying by 7 through, we shall be able to get 84y plus 7z, which is equal to that. And from here, we need to eliminate z. And to eliminate z, we shall do subtract. And we get 84 minus 13, which is 71y. This will give us 0. So we get negative 406. We subtract negative 51. And we shall be able to remain with 355. So this will mean that our y will be same as 355 divided by 71. This is a minus. So negative 355 divided by 71. And this will give us negative 5. This will give us negative 5. So the value of y will be negative 5. So from there we go on and get the value for z. So we can say from equation number 4, from equation number 4, we have 12 times y, which is negative 5, plus z, which is equal to negative 58. So from here, we shall be able to get z as, so we get negative 58 plus negative 58 plus 12 times negative 5. So that will give us, that is negative 58 plus 60, and that is positive 2. So the value of z will be positive 2. So after getting the value of z, we go on and get the value of, the value for x. So we can refer to equation number 1. So we can say from equation 1, and equation 1 says that we have x plus 3y plus 2z, which is equal to negative 13. So this is same as x plus 3 times y. We got our y as negative 5, then plus 2 times 2, which is equal to negative 13. So x minus 15 plus 4 is equal to negative 13. So x will be equal to, this is negative 13 plus 15 minus 4. So the value of x will be equal to negative 17 plus 15, which is negative 2. So therefore, the value of x is negative 2, y is negative 5, and z is positive 2. So these are the required values for x, y, and z. Now looking at question number 2, it says prove that cos 3a is equal to 4 cos to power 3a minus 3 cos of a. So let us look at the solution. So here we shall be using the angle addition formula. So we shall express cos 3a, using the angle addition formula. In other words, we express cos 3a as cos of 2a plus a. So this is the angle addition formula. So from here, we expand using the cos expansion, though it will give us cos 2a, cos of a, minus a sine of 2a, then a sine of a. So from here, we shall substitute the double angle identities. So the double angle identities, we have that cos of 2a. Since we need everything in terms of cos, we shall have it as 2 cos squared a minus 1. Then we shall have sine 2a as 2 sine of a cos of a. So doing that, we shall be able to obtain this as 2 cos squared a minus 1 into cos of a, then minus 2 sine of a cos of a, then times sine of a. So from that, we shall be able now to expand the expression. So when we expand this expression, we shall get 2 cos to power 3a minus cos of a minus 2 cos of a, and sine will give us sine squared of a. So this would be able to give us 2 cos to power 3a minus cos of a minus 2 cos of a. We shall apply here what we call the Pythagorean identity, and we know that the Pythagorean identity is that if you have sine squared plus cos squared, you get 1. So making sine squared this subject, we shall be able to get 1 minus cos squared of a. So from here, we shall try to again expand and combine like terms. So 2 cos squared of a minus cos of a minus 2 cos of a, then plus 2 cos to power 3 of a. So collect like terms, this and this will give us 4 cos to power 3a, then minus this and this will give us minus 3 cos of a. So this is cos of 3a, and that is the required expression. So you'll be able to get your 5 marks. So from there, we look at question number 3. Looking at question number 3, it says the period t of a simple pendulum of length L is given by t, which is equal to that, where k and g are constants. If the length of the pendulum increases by 8%, find the percentage increase in t. So let us look at the solution. So looking at what we are given t, which is equal to k square root of l divided by g. We shall try to simplify this expression. In that this same expression can be written as k divided by the square root of g, then times the square root of l. If I remove this g, since g is a constant, I can try to put it out, and I will have it as k divided by the square root of g, then times the square root of l. So looking at this, you realize that this one here is a constant value, because we have k divided by the square root of g. So from here, it implies that t is actually proportional to the square root of l. T is actually proportional to the square root of l, since this is a constant. So what we can do from here, we can let c to represent for us k over the square root of g. So if c represents this, since here we are dealing with a constant, so it means c is representing our constant value. So it will mean that t will be equal to c times the square root of l. This can as well be written as c l to power a half. Square root of a number is same as power a half. So this is t equaling to c l to power a half. So this is our equation number 1. We shall be differentiating this equation with respect to l. So from here, let us differentiate 1 with respect to l. So let us differentiate 1. If differentiate equation 1 with respect to l. So when we differentiate with respect to l, it means dt over dl will be equal to a half c l to power negative a half, which we can write as c a half c then times 1 upon l to power a half. So this can as well be written as c over 2l to power a half, and this will be dt dl. So we have dt dl as that. So this is our expression number 2. But we are given, from what we are given is that if the length of the pendulum increases by 8%. So if it increases by 8%, it means we are given delta L. We are given delta L over L, the rate of increase. This is the increase in length L. So the increase in length L is 8%. So it means that is same as delta L divided by L. So delta L divided by L is given as 8%. That is 8 over 100. In other words, this is 0.08. So we are given a delta L as, we can easily get delta L as 0.08 then times the length L. So we can call this one equation number 3. So from the given information, we are able to get a delta L as 0.08 of L. So from that, we shall go on and look at what we are interested in. We are interested in the percentage increase in t. So it means we are interested in getting delta t over t, the percentage increase in that. We are interested in that. So for that case, let us create the relationship between dt dl with delta t and delta l. So we shall be using the expression that if L is small, then it means delta t over delta L is approximately equal to dt dl. We know this. If delta L is small, if the increase in L is very small, then this one is true. And for that case, we can easily get delta t here as dt over dl, then times delta L. That is what we shall get if we make delta t the subject. So from this given point, we already have dt dl, we already have this, but we are interested in the percentage increase. So we are interested in getting the expression delta t over t. So to introducing t, we shall do divide on both sides by t. So let us divide both sides by t. So delta t over t will be approximately equal to dt over dl times delta L divided by t. But t is same as c L to power half. So it means this is c L to power half is square root of L. So we shall have that. So that is basically what we are having so far. Since we are interested in this, then we shall now substitute by dt over the L. So delta t here over t is approximately equal to, this is approximately equal to dt, the L, we have that from equation number 2. From equation 2, we shall have that. Then delta L, we have it from equation 3. So actually here we can say from equation 1, from equation 2 and 3, from equation 2 and 3, we shall have delta t over t as approximately equal to, dt dl is this c upon, this is c upon 2 square root of L. Then the L, next we have delta L. Delta L is 0.08 L. This is 0.08. This is 0.08 L. Then we are dividing this by, c square root of L. We are dividing this by c square root of L. So this will be same as having what we have here is equal to, c will cancel out. This is 2. This will give us 0.04. This will be L upon square root of L times square root of L will be L. So this is same as having 0.04. So in other words, this will imply that delta t over t is approximately equal to 0.04. So from this, it means that the percentage, the percentage increase in t is actually 4%, because this can be written as 4 divided by 100, as we have this as delta t over t. So delta t over t can be written as this, and for that case, if you multiply by 100 on both sides, so you are dealing with delta t over t times 100, which is equal to 4 over 100, then times 100. So delta t over t times 100 is actually equal to 4. So this implies that therefore the percentage increase in t is 4%. The percentage increase in t is 4%, and that means our question number 3 will also be answered. Let us now look at our question number 4. It says a line passes through 2 points whose position vectors are, we have I plus 5j minus 3k, then for I plus 3j plus k, determine the Cartesian equation of the line. So we are given the position vectors, this and that, and we shall now write this in coordinate form. So we shall let this point here to be represented by 1, 5, negative 3, this point here to be represented by b, which is 4, 3, and 1. So remember that the equation of the line is given by r, which is equal to a plus lambda t. That is a, that is a point through which the line is passing. D is the direction vector. So what is very important here is to get the direction vector first. So here we have identified our coordinates of the points that the line is passing through, and next we want to find the direction vector. We want to find the direction vector, and that is vector d. So d is same as ab, and ab is actually same as ob minus oa. So that is same as having 4, 3, 1, and subtracting 1, 5, negative 3. So this is same as having 3. This is 3 minus 5, which is negative 2, and 1 minus 3 is actually 4. So our d will be same as 3i minus 2j plus 4k. So having got d, we can now obtain our r. So r will be same as a. Let us use this one here, that is 1, 5, negative 3, we shall be adding the lambda into 3, -2, and 4. And from here, this is actually same as having 1 plus 3 lambda, 5 minus 2 lambda, -3 plus 4 lambda. So I want us to express this r in terms of x, y, and z, since r is a general point on the line. So we can have this as x, y, and z, so which is equal to 1 plus 3 lambda, 5 minus 2 lambda, then -3 plus 4 lambda. So from this given point, we need to get the value of lambda, or we make lambda the subject out of these expressions. So we shall have 3 expressions, that x is equal to 1 plus 3 lambda, which implies that lambda is same as x minus 1 divided by 3 when you make lambda the subject. Also, y is same as 5 minus 2 lambda, and this implies that our lambda is same as y minus 5 divided by -2. Also, we have z is equal to -3 plus 4 lambda, which means that lambda is same as z plus 3 divided by 4. So from that, we can now convert what we have obtained here into the Cartesian form. So therefore, we can now say that this implies that lambda is same as x minus 1 over 3, which is equal to y minus 5 over -2, which is equal to z plus 3 over 4. So from that, we can now have the Cartesian equation of the line as, so thus the Cartesian equation will be, so we shall have x minus 1 over 3, y minus 5 over -2, z plus 3 over 4. And this will be the required answer. So let us look at question number 5. It says solve the differential equation e to power x dy dx is equal to -x, and we are given that y of 0 is equal to 2. So we shall look at the solution. We are told that e to power x dy dx is equal to -x. So looking at this differential equation, we realize we can easily separate the variables, and for that case, we shall first divide through. Let us divide through, or divide both sides. Let us divide both sides by e to power x. So when you do that, it will imply that we shall have dy dx, which is equal to -x over e to power x, but this can be written as -x e to power -x. So in other words, we are having dy dx, which is equal to -x e to power -x, and from here we can have this as dy, which is equal to -x e to power -x dx. So from this given point, we shall integrate on both sides. So next we shall integrate on both sides. So integrating on both sides, we shall have this as integral of dy, which is equal to the integral of x e to power -x dx. So from that, you look at this, this will be the integration by parts. So this will give us y, which is equal to negative of, so this will be negative of. So from here we shall let, we shall be letting u to be x and dv dx to be e to power -x. So next here we need uv minus the integral of v du dx, then times dx. That is basically what we need at that given point, then plus c. So in other words, our u is x, our du dx will be 1, and our v, so this will imply that du dx is 1, our v is negative of e to power -x. You integrate e to power -x, so the derivative of -x is -1. So you have to divide by -1, which will give us negative of e to power -x. So this means that we shall have y as negative of u is x, v is negative e to the power negative x, minus v negative e to the power negative x, then du dx is 1, then dx, then plus c. So this would give us y as negative of negative x e to the power negative x. This is plus integral of e to the power negative x dx, then plus c. So this will give us y as a negative of negative x e to the power negative x minus e to the power negative x when you integrate this, then plus c. So y will be same as x e to the power negative x plus e to the power negative x, then plus c. So that would be y. So this can be written as x plus 1 e to the power negative x, then plus c, and this will be y. So after getting this, then we are told that y of 0 is equal to 2. This means that y is actually 2 and x is actually 0. So substituting in this, we shall be able to get 2 which is equal to 2, which is equal to, so x is 0, that is 1 e to the power 0, so that will remain 1. So this will be 1 plus c. And this implies that c is equal to 1. So the value of c is equal to 1, and from that we shall therefore say, therefore y will be equal to x plus 1 e to the power negative x plus c, which is 1. So from here we shall be able to obtain this as the value for y. So solve the differential given that. So this will be the required answer. So the value of y will be equal to this. Question number 6 says expand f of x, which is equal to e to the power x sine of x using Maclaurin theorem up to the term in x squared. So we are given f of x as e to the power x sine of x. So we need to recall the Maclaurin theories. A Maclaurin theorem is the Taylor series expansion about x equaling to 0, and it is given by the series is given by f of x, which is equal to f of 0 plus f derivative of 0 of x plus f double derivative of 0 of x squared divided by 2, then plus other terms. So our interest is to compute each of the derivatives, that is f derivative of 0 and f double derivative of 0, since we are interested in expanding up to x squared. So for that case, let us see how best we can get f derivative of 0, f of 0, and f double derivative of 0. So this is the Maclaurin's theorem. So this is the Maclaurin theorem. So we need to substitute in this expression to get f of x expanded up to the term in x squared. So let us compute. Let us try to compute f of 0. F of 0 is same as from f of x equaling to that is same as e to the power 0 sine of 0, and e to the power 0 is 1, sine of 0 is 0, so this gives us 0. So for that case, let us now proceed and compute. Let us compute the first derivative. Let us compute the first derivative, and after that we get f derivative of 0. So computing the first derivative, that is f derivative of x, will be same as applying the product rule here. So we call this u, we call this v. So u is e to the power x, v dv dx. So we use, let us try to put it here, that is u dv dx plus v du dx. That is the product rule that we shall be using. So that is e to the power x times cos of x. Then that is u, then we differentiate this to get dv dx. Then next, sine of x, we differentiate e to the power x, it remains e to the power x. So in other words, we shall be able to get e to the power x into cos of x plus sine of x. So this is f derivative of x. We go on and obtain f derivative of 0, e to the power 0 cos of 0 plus sine of 0. So this is 1 times cos of 0 is 1 plus 0, and this will give us 1. So next, let us compute from here we need the second derivative. So let us compute the second derivative. We shall compute the second derivative, and after we find f derivative of 0, f double derivative of 0. So next we shall have f double derivative of x, and this is obtained by differentiating f derivative of x. So we shall differentiate this. We shall call this u, e to power x is u, then we shall differentiate v. V is this, cos x plus sin x, which will give us negative sin x plus cos of x. And then next we shall have our u, which is cos of x plus sin of x, and we shall differentiate e to power x, which remains e to power x. So basically that is what we shall have. So you realize that e to power x will still be the same, so you will simply add this, sin x will cancel, you get 2 cos of x. So this will give us 2 e to power x cos of x. So having obtained that, let us get f double derivative of 0, which is same as 2 times e to power 0 cos of 0. So this will give us 2 times 1, and this will be equal to 2. So this is f double derivative of 0. So from this, we can call this one equation star. So from our equation star, we shall have. So next we are saying applying. Let us apply Maclaurin's formula up to x to power 2. So in other words, we are referring from equation star. We are referring from equation star. It means our f of x will be equal to f of 0 plus f derivative of 0 of x, f double derivative of 0 of x squared over 2 factorial plus other terms. So this will give us f derivative, f of 0, let us substitute that, f of 0 we got 0, the next was 1, the next was 2. So we shall have 0 plus this was 1 times x, plus this was 2, of course we divide by 2 factorial of x squared, plus some other terms. So our interest is up to x squared, so we shall have this as x, plus 2 divided by 2 factorial, that remains 1. So we shall have x plus x squared. So f of x will be equal to that. So therefore, according to the equation, we need Maclaurin's series. We need to expand this up to the term in x squared. So therefore, we can easily say that e to power x, a sine of x, when you expand it, will be x plus x squared. Let us look at question number 7, and please don't forget to subscribe to this channel. If you are finding this video helpful, kindly hit the subscribe button. Don't forget to like and share this video to your friends. So we are looking at question number 7. Question number 7 says a variable point p of x, y moves so that the ratio of its distances from two fixed points q is given as negative 2, 0 and r is given as 2, 0 is pq to rp is equal to 3 to 2. Show that the locus of P is a circle. So we want to interpret this given information. We are told that Q is a negative 2, 0 and R is 2, 0. So a point P is a general point which is given by P of xy. So we are putting our point P at that given point. And next we are told that the ratio of its distances from these fixed points is this. So we have PQ to RP. PQ, we are told that PQ, this distance here to RP, is 3 to 2. That is what we are told. So we are told that PQ to RP is 3 to 2. So if we have PQ to RP at 3 to 2, so it means we can go on and have this as PQ. We cross multiply here and have 2 PQ is equal to 3 RP. So since we are considering distances here and we know how to get distance between 2 points. So if you have PQ, you can easily get the distance. RP, you can easily get the distance. So what is this? This will be 2 times the distance between P and Q can be is obtained by getting x minus 2 squared plus y minus 0 squared. So this will be equal to 3 RP. RP, we are considering these 2 points, so I can get this as the square root of x minus 2 squared plus y minus 0 squared. So this will be same as 2 square root of, this is x plus 2 squared plus y squared, which is equal to 3 square root of x minus 2 squared plus y squared. So I want to get rid of these square roots, and I will do so by squaring on both sides. So when I square on both sides, so squaring on both sides, to eliminate the square root signs, so I will have this as 4. I will square this, then have this one also. So this will be 4x plus 2 squared plus y squared. This will be equal to 3. So this will give us 3 squared. That will be same as 3 squared. That will be same as 9 into, this is x minus 2 squared plus y squared. Please, when you take the square, when you square on both sides, don't forget to square these terms as well. So this would be same as having, we can try to simplify this as 4 into, this is x squared plus, this is x squared plus, this will give us 4x plus 4 plus y squared, and this will be equal to 9 into x squared. This is minus 4x plus 4, then plus y squared. So we shall try to simplify this expression. We shall have 4x squared 16x 16 4y squared, which is equal to 9x squared minus 36x plus 36, and this will be plus 9y squared. So from here we shall try to simplify this further, and this will give us 4x. We take everything the other side, so 9 minus that will give us 5x squared plus, so 4y squared taken the other side, 5y squared as well. So next we shall have, when we take x the other side, that is minus 52x minus 36 minus 16 minus 52x. Then we take y. When you take, we don't have y this side, so we take the constant. So 16 36, that will be 20. So this is plus 20, and this should be equal to 0. So from this given point, we can divide through by 5 to give us x squared y squared minus 52 over 5 of x, and then 20 divided by 5 will give us a 4, and this will be equal to 0. So from here, let us complete the square for the circle equation. So we need now to show that this is in form of a circle, and for that case, let us first try to make completing squares here. So I want to consider x squared minus 52 over 5 of x. Then this one can be written as y. This can be written as y minus 0 squared. Then we are having 4, which is equal to 0. So from here I want to use completing squares. This is x squared, so minus 52 over 5 of x. So I will add here, when you get 52 over 5, you divide it by 2, so it is same as 1 over 2, that is 26. So I will have plus here 26 over 5 squared. I will again subtract 26 over 5 squared, and I will add there y minus 0 squared plus 4, which is equal to 0. So from this, I will get this as x minus 26 over 5 squared. This one here will give us that. Then I will have to add there y minus 0 squared. So next I will take these ones the other side. So I will have negative 4 plus 26 over 5 squared. So finally, I will have this as x minus 26 over 5 squared plus y minus 0 squared, which is equal to, so this will give us 576 over 25. So this basically can be represented as x minus 26 over 5 squared plus y minus 0 squared, which is equal to 576 is same as having 24 squared. So this is 24 over 5. 24 over 5 is same as 24 over 5 everything squared. So that will be the equation of a circle, which we can now easily get its center. So from this we can easily say that this one here, this is the equation of the circle. This is the equation of the circle. This is the equation of the circle. With center. So the center is 26 over 5 and 0. And the radius. So radius is 24 over 5. And that will also be answered. So therefore, the locus is a circle. Therefore, the locus is a circle. So question number 7 will also be answered. So lastly, for section A, we shall have question number 8. And please, as usual, don't forget to subscribe to this channel. This is very helpful, especially to ensure that our videos reach a wider community. Please make sure you subscribe, like, and share this video to your friends. So let us look at the last question for section A, which says solve the equation log₅ of A plus 2 log A of 5 is equal to 3. So we shall look at the solution. So from here, this will involve a change of base and substitution. So basically, you look at the bases. This is 5 and this is A. So you ensure you change the base first. So let us look at the solution. So we shall try to change the base first. And so we shall have log₅ of A plus 2. I will change the base. We understand that if you have log A of B and you want to change it to log C, this will be log C of B, log C of A. For that case, we shall have this as log₅ of 5 over log₅ of A, and this should be equal to 3. So this will give us log₅ of A plus 2 times this is 1 over log₅ of A, which is equal to 3. So we shall realize that this and this are common, so we shall let U to represent log₅ of A. So for that case, U plus 2 divided by U will be equal to 3. So U squared plus 2 is equal to 3U. So U squared minus 3U plus 2 will be equal to 0. So having got that, so this is a quadratic equation which we can easily solve using some different methods of solving quadratic equations. So we can look for the factors of 2, which we multiply together to give us 2, but when added to give us 3. So that will be same as minus 2u minus u plus 2. In other words, it is 2 and 1. But this and this must be negatives. The product will give you 2, the sum will give you negative 3. So this will be u into u minus 2. Then we shall have minus. This will be a minus. So this is minus. So we are having u minus 2 here, but we need to obtain this. So we shall put minus 1 out. So we can get this, and this is equal to 0. So u minus 1 into u minus 2 will be equal to 0. So from here, either u will be equal to 1 or u will be equal to 2. So we shall be able to get the values for u. So u is 1 or u is 2. But we understand that u is same as log, but u is same as log 5 of a. So let us consider u equaling to 1. So this will imply that log of 5 of a is equal to 1, and for that case a is equal to 5 to the power 1, and this is 5. So next, when we consider u as 2, so it implies that log 5 of a will be equal to 2, and this will imply that a is 5 to the power of 2, which is equal to 25. So from here, that will be a. So therefore, the values for a will be equal to 5 and 1. So therefore, a is equal to 5 or a is equal to 25. But you can also check and see if it is satisfying. So log 5 of 5, that is 1. Then a is 5, we are beginning with 5. So this is 1 plus 2, which is equal to 3, and that is true. Still, when you put 25 as a, so this will be same as log 5 of 25, then plus 2 divided by log 5 of 25. So this will be 2 plus 2 divided by 2, 2 divided by 2. So this will give us 2 plus 1, and that will be 3. So all of the 2 will be satisfied. So therefore, a will be equal to 5, and a will be equal to 25. So that marks the end of section A. Please, if you find this video helpful, don't forget to subscribe to this channel, and we shall be now looking at section